So welcome to the ASDF working group. And we'll just go through things here. There we go. So note well, you've probably seen this already, but if you haven't, then please take a look at the note well, ask some questions, and there's quite a number of people that you can come to, friendly ADs, working group chairs. Please be nice and professional. We're a pretty small group, so if you have something to interject, then to the extent of politeness, please just do that. You can just turn on the mic, or you can go in the queue if you aren't ready. If you aren't trying to speak to the point, but you have another point, then put yourself in the queue and we'll get to you. But if you would just want to interact on a particular point, then I would say don't stand on the queue at this point. So there's some more details of the note well. You want to know what's going on, read BCP 9 and the other ones there. I'm sure you've all seen it. So today we're going to go through a bunch of things, specifically status update on the group, and then we're going to get right into the SDF 1.1 features and the results from the hackathon. Is there any other items that someone thinks needs to go onto the agenda at this point? Now's the time to ask. Hearing none, we're going to move on. So there is a Kodi IMD which is an Etherpad for the notes. Ari is adding things. Please feel free to add, correct, and copy and paste as you wish into it to things. We are using Meet Echo. If you aren't on it, then you probably can't hear me, but you may be on the audio queue. There is a Jabber room that you can connect directly to, or you can also click on the tab with the two red, well, they're red on my screen, balloons to there. And the blue sheet is managed by Meet Echo, so you don't need to do anything, and we have a note taker already. So our working group was in fact chartered finally in October. My name is Michael Richardson, and my colleague is Nicholas Waddell. We are the co-chairs of this working group. So hello, and thank you for coming. We had a bit of a hallway meeting as the working group was still in the forming process, and we did a bit of a YouTube SDF 1.0 tutorial. So basically the results of that are on YouTube. If you want to know a lot about SDF then and how it came to be, then please go there, and we'll be doing a few minutes of that here. We did have one virtual interim, November 2, as I recall, and we adopted the initial draft, IETF, ASDF, SDF. That's a bit of alliteration there. And so that is our 1.0 at this point, and we are working now on 1.1. There was a hackathon, which we're going to hear about last week, where a number of issues with or limitations with what we've called 1.0 were discussed and some solutions found. And today our plans are basically to have this meeting, and then we're going to plan essentially a virtual interim on approximately a monthly basis. And so we're looking to schedule one in December, middle way. And hopefully that time period that we pick for December will repeat every month for a number of months. So we have a mailing list. If you're not on it, you can get on it by going to this link, standard mailman type process. We are working in GitHub with the RFCs typically, so you will see issues being discussed in GitHub. Nicholas and I believe we have not yet hooked up the GitHub summary to mailing list webhook. But we will be doing that, so there will be at least a weekly summary coming to the mailing list of things that have occurred on GitHub. And we will, of course, expect that the authors will bring any large contentious type issues to the mailing list for a summary of what's going on there. And the goal of the working group is we are going to be running in a kind of implementation draft where we will say that certain things are relatively stable and could go into code, and other things may be less stable, but we'll basically identify which documents are considered stable enough to be implemented by the various filtering converters that are already out there, the tool chains. And it's a goal after a couple of iterations of this that we will get to the point where we're ready to publish a RFC. So I'm turning this over to you, Nicholas, to give us the short tutorial, the 5-minute version.
Yes, or even a 2-minute version. We have, as Michael said, we have done tutorials previously, but this is just to give you a brief overview of what this is all about, or where this came from, the SDF work and so on. The problem we started out with 2 years ago was basically that there were several standardized IoT data models, and the OCF, OMA, ZigBee, and so on. And so while they were standardized, they were not really compatible. And while they could be made to work together, there was a high integration cost because there is basically no sort of standardized interoperability between these models. And so there was a group formed called One Data Model and liaison group between these couple of different SDOs. First, we tried to address this by selecting one solution, but that did not work. And then we came up with the solution to actually, instead of trying to select one, we actually introduced a new layer that facilitates translation between the different data models via a neutral format that was that could help with this translation. And this proved very successful. So we have translation established between a couple of these different ecosystems via this neutral format. And this neutral format is what's the topic about today, the semantic definition format, and which is now in IETF. So this slide was used a bit old, but it's now in IETF as this working group. And so in addition to the work in the ASDF group, there's also the work in the One Data Model liaison group. There's a link to it at the bottom here. Please go there if you want more information, because they are doing a couple of complementary things to the stuff in ASDF. So while the format is defined, specified, and developed in IETF, there is work on tool chains, work on sort of enabling this interoperability between the ecosystems, and also there is work to define a set of harmonized thing models or device models that can be used widely across these different ecosystems. So this was just a super quick recap to give you some frame of what this is all about. And so the rest of this meeting, of course, will be around SDF and the work in the ASDF group, but this provides some frame about what this is all about. Yes, next slide. So just a few words around the ASDF work. As Michael said, we just kicked off. This means that we would like to reach out to additional organizations. We start out with the organizations that are in 1DM, of course, but we are super happy to bring in others. And obviously, the value of ASDF increases with the more that other organizations join, and we can create interoperability between all the larger set of organizations. So far, in the short period since we launched, we have been doing two things. One is we presented the ASDF work to OMA's Beckworks, DMSC group, working on Lightweight M2M. And another thing is that SDF, as the previous version, is now part of a proposal to ISO IEC JTC1 SC41 for IoT thing modeling in their architectural work. And this will, of course, eventually refer to the final RFC coming out of this group. So this is a bit of a call to action. If your organization works with IoT data models and you're not already involved, please let us know and talk to us, and we can try to loop you in and bring you on board in this. Yes, that was all.
About from Eve about what kind of responses were received in LWM2M and the JTC1. Are you in a position to relate what happened there?
Oh yeah. Oh sorry. Yeah. So in Lightweight M2M or in DMSC, the response was, this looks interesting, and we want to look at it and discuss it more. Of course, it fits, since one of the groups going into this work was the IPSO group in MS Specworks, and obviously the models are very much related. So it's a pretty good fit. But then, of course, it is also a kind of you need to do some translation. And on the ISO JTC1 SD41, it's actually will be on discussed tomorrow. So I don't have a. It's a new work item proposal being submitted from the Swedish standards unit, but it's not yet decided on how to bring it forward. But it's part of it. So the awareness has been raised in this community as well about this work. Good point. Thank you.
Okay. So I think I'm supposed to speak to the next few slides. I'm Carsten Bormann. I got dragged into the 1DM work about a year ago, and I have not invented anything that's in there. I have just tried to make it a document that people can use that ultimately will be able to get standardized. So let's talk about this weird numbering scheme here, SDF 1.1. Usually in the IETF, we number things -00, -01, and so on. And what we are trying to do here is have a few of these dash something versions be qualified as implementation drafts. So they kind of represent, that's the objective, they represent working group consensus at the time with a full knowledge that we will learn new things when using it, and therefore we'll need to make further iterations. So SDF 1.1 will be a -03 or -02 or whatever happens, that we actually have had something like a small working group last call for, and we agree we want to publish this, well, not really publish, we want to label the internet draft as SDF 1.1. And we probably will have a 1.2 and a 1.3 and maybe even a 1.4 before we actually submit this to the ISG as a standards track for submission as a standards track RFC. So that's when I talk about SDF 1.1, we are according to my reckoning, about halfway on the way between 1.0, which was the initial submission to the IETF, and 1.1. And next slide. So we have collected a number of open issues in the GitHub. That doesn't mean we will not look at any other open issues anymore after we have closed these. But these are the ones that apparently received the largest amount of interest from people who wanted to convert their ecosystem-specific data models into something that can be expressed in SDF. I'm going to go through these issues in more detail later. Issue number 3 really is about something that already is in SDF 1.0, but we hadn't really tested enough yet, so we had to do the validation. And one tiny thing came up that we termed number 7. So how do you use these references? Can you override? Can you augment them? Issue number 4 is we punted on supporting compound data composition for 1.0, and I think we now understand what we can do there. So that was one of the results of the hackathon. And then the third big area is one of expressing not conjunction like here, but disjunction. So you have a choice between different alternatives. And we had 2 proposals, one based on enums, one based on JSON schema orgs, any of and I come to a proposal how to work with that later. Next slide. So at the hackathon, we mostly tested out the view we have of issue 3. We came up with a convention on using the queries that is a little bit surprising. Come to that in a minute. And we discussed how we can manage these namespaces in a way that supports the progress of a model from an ecosystem model to a converged model, and well, the various transitions while in those stages. And on issue 4, well, we used the discussion about compound types or aggregation to also fix a few warts in 1.0. So with that, let's, next slide, jump into issue number 3 and a little bit issue number 7. Next slide. So we can, instead of writing something into the model, we can write a reference into the model, and that reference points either to a different place within the same model or to a different model and imports some spec. This is based on JSON pointers right now, and we generally know that JSON pointers work, so that was not an issue. But we weren't so sure that the way the space is being managed was a good way. And we also never really tested out what we can reference there. So initially this focused on data types via SDF data. And I think we are not completely done with thinking about referencing other things. Next slide. So here's an example. Let's say we have defined a data type that we call length, and that is obviously a number. Length cannot be less than 0. The SI unit is meter. Oh, this is using the old name, sorry. And there's also a description, well, that probably needs to be longer than here in this example. And then later on, if we have the cable length measurement from the TDR unit in a router, then this can give us something that is like a length, but the TDR unit really cannot show anything about cables of at least 5 centimeters. So we actually modify this description a little bit. So this is one example where we had to decide whether we want to allow this kind of overriding. So this is actually following the Liskov principle here, because the second one is a subset of the first one. But of course, when you can override anything, you're not forced to follow the Liskov principle. Next slide. So in practice, this would occur in an SDF property declaration, and so SDF data is just a place where you can define things that can be referenced, or data types that can be referenced, and this is not by itself declaring an affordance. The affordance is declared in the SDF property. So there is something called cable length that you can read out from the device. Next slide. So when we do this between different specifications, then of course we have to manage a namespace that is much larger, and we decided to have a global namespace that is based on URIs. These URIs are not necessarily meant to be resolvable, but they are names. And using a namespace table and a default namespace, we can say that the length that is being declared up here in the yellow part, defined actually, not declared, that can be referenced in the white part using an SDF ref that points to that namespace. And interestingly, the namespace names can differ. The interesting part about the namespace is not its namespace name, which is a local matter in a specification, but the URL. So the white part says namespace foo is example.com, and so we can reference it from there. So that's how the slide looked a month ago. And now next slide. We have changed this a little bit, and you probably had to watch closely to see the difference. So we actually moved the hash mark down to the reference. And why does that make sense? Go another slide forward. That leads to uniform reference, because the reference to a local item looks the same way now as a reference to an item that is in the default namespace. So you can actually take out parts of a spec, put it somewhere else without having to edit the whole spec. And that's a win, although it's a little bit more conventional in the RDF community to have the hash mark in the namespace definition and not in the reference. So that's one of the things that came out of the hackathon. So that's, I think, pretty much resolved. We think we understand how this is being used, and in the exploratory part of the 1DM repository, we have a couple dozen examples that make use of this in one or the other way. But of course, so we should use all time we have to experiment further with this and find out whether we maybe also want to use this in different contexts than just referencing data types. And Michael says in the chat, please step up if you have questions about this. And Christian asked, the semantics of queries are still plain concatenation, and the answer is yes. So what really happens here is that the hash /SDF data /length is appended to HTTPS example.com. So the path part is what gives you the uniqueness, and the part behind hash is a fragment identifier, a JSON fragment identifier that takes the form of an RFC 6901 pointer, JSON pointer, that says up there in that document, look under SDF data length, and you find it there. I find myself, I'm so used to Big Blue Button as a conferencing system that I'm pointing to places, and Echo doesn't support that. Sorry that you cannot see my pointer. Yeah, exactly, yeah. So any more questions about issue number 3? So of course, you all should read the new text that is in -01 about this and check whether it fully represents this. But I think that this is also pretty much non-controversial, or should be. Next slide.
So this means that issue 3 can be closed, right? Or
not quite. So there's this. If you go to slide 14, there is this little question of, can we import entire affordances or even more? Could we import a whole SDF data section? So I think that needs to be understood, what that actually means, and or whether we are limited to essentially pointing to something that is below SDF data. So that small part, maybe we should make a new issue out of that so we can close number 3. Okay, so let's move on to slide number 20.
Karsten, I just want to clarify. So what you're saying is that we can't point at, for instance, type. We can only point at length. Is that what I understood you to say?
That's what I'm proposing.
Okay, just wanted to make sure I understood the statement.
Yeah, so you can write down a JSON pointer for anything. The question really is what are the JSON pointers that are valid in an SDF ref? There's also SDF required, which probably has a different set from the SDF ref set. So for both cases, we should decide which are the sets of things that these pointers should be pointing to. Okay. Thank you for the questions. Issue number 4. So this is about composition or aggregation, as I have been calling that, or compound types. We have many terms for this. It essentially means that we are constructing something out of multiple parts. And we punted on that for SDF10, but we couldn't completely punt it, so we had something awkward for composing parameter lists. And this is on the way out now that we have real composition. Yeah, so the thing that is on the second to last bullet here is really what exactly does the reference mean, and what actually should be overridable there, and can we compose affordances as well as just types. So next slide. So this is an example in the new syntax where we have two properties. One is called simple one. This could be the name of the device, and compound one, which might be the location of the device, and element one is the GPS coordinates, and element two is the street address, or whatever. So we have a compound property, and this, of course, could also be modeled as separate properties, element one and element two. But in writing such a specification, there is a certain tendency to group things. So it's useful to have the compound stuff. We decided to use the same syntax JSON schema org uses for JSON objects. And that's maybe a little bit confusing, because we are not saying that this property then is represented as a JSON object. Because we are at the information model level. We are not at the level where we would make representation decisions like that. But because we are using a data modeling language to represent information models, it's pretty normal that we use one way of representing things as a stand-in for the information model property that we are trying to represent here. And well, a JSON object is a good way to group things together into a bigger thing. JSON schema org also has a required, and that thing is called property, sorry. In the compound, the word property means at least three things here. So this can be used to say that certain of the map keys, key value pairs, are required and others are optional. This is a bit clumsy, but I think generally the feeling was that we want to stick with what JSON schema org is using there to follow the principle of least surprise. So that's where we came out. Next slide. And now that we have it, we can also use this to build the parameter lists for actions and events. So actions have input data and output data. And in 1.0, we essentially built the input data and the output data as arrays of references to SDF data, which means we could point to data, but we couldn't say what these data actually meant. So we can't say whether the intensity value that we are pointing to is a red, green, or a blue intensity value. And with the new way of structuring things, we have to write a little bit more JSON, but now we can actually put in names here. So for instance, the input data is the amount of squeezing you get from the hug, and the output data is the amount of comfort you get. Now, if you look at this, you may think, oh, there was a data type up there in 1.0, and that already had the information. And that works as long as all your input data elements have sufficiently different data types. But we ran into examples like the red, green, blue light, where the data types are actually the same, So the data type reference in 1.0 didn't tell you what it was. And now we get this in the name like squeeze or comfort here. So this is, once we made the decision to live with the fact that people might mistake with this with just plain JSON objects, I think this was a no-brainer. Yeah, this is the solution for aggregation and the little fix we could make based on this. So again, before we close number 4, we should think whether there are other kinds of aggregation that we need, but this kind of aggregation, data types and parameter lists, this is now taken care of. Questions? So let's go to the next slide. We have 2 issues, issue number 2 and number 5, next slide, that actually, when you examine them closely, are the same. Issue number 2 was about using something like the JSON schema org enum facilities, which allows you to define a type as a choice between a number of values. So you put in an array with values. And yeah, so this gives you values, but it doesn't really help you in actually defining what these values mean. So there is no place in JSON schema org enums to actually annotate them with any semantic tags. So this was not something that we could use directly, and for a while we had various proposals called SDF enums, which would be almost but not entirely unlike enums in that you had a way to put the semantic tag there. And the other thing was that JSON schema org also has an any-of operator that can be used to build a type union of multiple schema descriptions. In 1.0, we didn't include that. We were hesitant to do this because we hadn't examined alternatives or choices yet. So we could actually put this in, or yeah. There isn't much of a difference between the two because they both lack a way to put descriptive information on the alternatives. Yeah, that's what we looked at. We looked at a number of examples. And of course, the convenience value of the JSON schema org enums is that, as it's usual when you just give text strings, then you think you know what these things mean. But it actually turns out that that's not always very clear. And just from a single text string that looks like an identifier in a programming language. And there are also funny little things like typos in those text strings, which cause immense pain when you repair them, and so on. So it's not necessarily exactly the way you want to do things. Next slide. As usual, let's look at an example. So this was an example that had been handed around for a while. We have a property called state, and that has 2 possible values, on and off. And of course, we could model this as a Boolean, but that's not the point here. Let's say you want to give them explicit names. Then we would build an SDF enum with 2 alternatives on and off, and we can put descriptions there, and we can give the things labels, and so on. So the labels are a bit redundant. We don't really have a semantic foundation here. Of course, we can read the description, but somehow it would be nicer if we could put a pointer to some RDF in here. Yeah, and we can write comments, and we might even put other things there, like ecosystem translations or whatever. So this is extensible. Next slide. So I hope you can read this. Very nice. Yeah, that may be a bit much. 125 is probably the next you can do. Okay, so another example is right from, I think, was it Zigbee or Bluetooth? I don't remember. So they have a 1 byte number that can go from 0 to 255. And a number of these numbers, 1 to 254, are reserved to actually give a startup level. So when you switch on the device, the lamp goes to intensity 1 to 254. And there is also an SDF enum in the NEOF alternative here that has 2 additional values: minimum device value permitted, which is 0, which is represented by 0, and set to previous value, which is represented by 255. So I'm not going to explain the logic of this device. But the basic idea is that we have various alternatives here, and the difference between NEOF and SDF enum makes us doing interesting nesting here, which maybe is not something we always want to do. There's also the question whether the numbers that are given there really are information model level content or are not. So there are some industry standards where it's not hard to say, most RGB devices have something that's going from 0 to 255, so let's go with that. But there are other things where really different ecosystems have different numbers, and we have to work about mapping files to handle those. And if you look over into the issue behind this, then you see one example from the Michael Costa how such a mapping file could look like. Next slide. So this is just an intermediate example. This is not even JSON syntax, but I think you can see what's going on here, which was an example of having 3 number ranges: 0 to 86, 87 to 166, and 167 to 255. And these have different semantics, which are encoded in the label there. So the choice mechanism might be used for actually giving different semantics to different number ranges, which is going one step further than the previous example. Next slide. Yeah, this is the same thing in JSON syntax. Next slide. So the decision we really had to make is a choice just a type union? So the various types that we unify are essentially opened up, and all the values are put into a big basket, which is the type union. So if values actually occur in several of the branches, the assumption is that the same value means the same thing in each of the branch. So that's a type union. And when we did the CBA encoding of Yang, this was probably the most expensive feature to have type unions like this. The alternative to that is to say a choice is a set of named alternatives. So we actually want to attach semantic information to each branch. We want to label the graph that we set up here. And by putting in names, we can also put in other descriptive information like RDF references and so on. And my proposal for today is to always go for named alternatives. Next slide. Yeah, this is just recapping how JSON schema org does this. Maybe next slide. The state example essentially just replaces SDF enum with choice. It's otherwise the same thing. Maybe we don't need the labels. We can probably use the branch names as default labels, but you can add labels in any data type in SDF. And we could also add semantic tags that ground this in some terminology. Next slide. And this is the example that mixed AnyOf and SDF enum, and we now have a single choice that has both kinds of alternatives integrated. So we don't need the unnecessary nesting. All the alternatives are named. So the top level alternative is now named actual setting, and it can have a description and so on. So that's pretty much the resolution that I'm proposing for number 2 and number 5. So if you can go back one slide again. Any discussion of this resolution here?
Should go back to the example that it was before, the one that we blew up.
Slide 27, yeah.
Yeah. Okay, have to click on the thing rather than the window. So this had an any of, and then it had a bunch of things down buried into it, right? And this one has this choice.
Yeah, so it's different from AnyOf because it's not an array, it's actually a map, a JSON object. And it's different from SDF enum because we are not giving values here, singleton values, but we are giving types, which of course in turn can be singleton values if we use something like const in the type definition.
We have Ari in the queue. Ari, go ahead.
Yeah, I saw Michael Foster also wrote a comment in the notes. Maybe Michael wants to go first.
Okay, Michael.
My comment, well, my first comment was that this also kind of resolves the dilemma we had between one of and any of in JSONschema.org, where there's really ambiguity about, they both really kind of mean the same thing. So this sort of takes that choice away and just presents an alternative that has one way of expressing things and not two. So that's pretty good. And also I'd like to just comment that in looking at trying to express the things from different ecosystems like Bluetooth and Zigbee, where they've done bit fields and things like that are combined, or rather value ranges that are combined. This is and really for the enum and for the other choices, this is really a natural pattern, I guess is really what I mean to say. This is something that I would be able to go to and not worry about whether there was some other way or whether I was doing it right. And that's really one of the bigger issues with building a language like this. The developers aren't experts in languages and config file formats. They just want to have, express a model. And so this provides a way, in my opinion, that a pretty good way to do that. Not that there might be better ones, but for now, this is a really good way that I think in all the different ecosystems could could use and benefit from.
Okay. Thank you. Ari? Well, you left the queue.
Yeah, well, I can comment now. I noticed I had a bit hard time following the discussion and taking notes at the same time. Maybe bit of background, like so we're now combining the enum and the choice. So pardon me, I don't quite remember our discussions we had before I went for my leave, so my brain has lost a few months of discussion. But can you go back to what we had earlier in the slides?
Slide 27.
Yes, and here it was, so we could have either the property would have either a static type or it could be an enum. Here's what this tries to express. Is that correct?
I don't know what a static type is, but among the types we have available are any kind of type and enums.
Okay, because maybe this example is perhaps slightly confusing without knowing the background of what the data model is actually trying to express.
But the background is that they had a byte and had to find a way to encode the various things they wanted into that byte. And it's funny that they don't have a maximum device value permitted, because a byte value can only have two extremes and not three. So we are trying to represent this choice between the actual setting, which doesn't have a name here in the AnyOf, and the instructions for deriving a setting where we have a minimum device and a previous value. And we are all trying to encode this into a single byte.
Okay, I see. So it's the same value interpreted in two different ways, in a sense. Like, I mean, same value on the wire.
The value is 0, 1, 254, or 255, or something in between.
Yeah, and if the value is 0, you interpret as an enum. If your value is 1 to 254, you interpret as a level.
Yes.
I see. Good.
That's really a representation thing and not information model thing.
Good. Okay, then if you can go back to the proposal.
And so if I was standing at the mic in a room, you probably would have seen me. But what I wanted to say was that the actual modeled intention of this pattern, if you had out of band things, you would have probably left the setting at 0 to 255 and would have created two exclusive out of band states. And so if I was rebuilding this from scratch, I would create probably two resources, one that had the settings and maybe three settings, one which would be value, the other would be minimum, and the other would be set to previous. And when I set it at value, it would use the scalar that was the value that would have the full range. But since they wanted to pack things, they took this other alternative. But you see that this pattern would be useful in modeling the intended pattern with the range that you wanted. It could be 0 to 255, and there could be two other things, and you would be free to map these in a mapping file differently if you wanted to, and implement them in any way you wanted, as long as you had the property of these being exclusive. And the fact that you express it as a choice does basically say that you want it exclusive. And this is what I mean by saying it's a natural pattern for implementing what the higher level intention, the semantic intention behind the weirdness in the model.
Okay, thanks. Now I understand. I think, yeah, this seems like a useful pattern, especially when you're trying to represent ecosystem-specific things as accurately as possible. Probably for the consolidated models, we would choose a slightly different way and then have it easier mapping to other systems, but ecosystem-specific models. Now I understand the use case here.
That's
Okay,
right. The values would go into a mapping file, but they're shown here just as a convenience so we can visualize the pattern.
Mm-hmm. Okay.
So, Ari, you had one comment.
You're allowed to put these constraints in if you want, but normally you would want to do it in a way that's flexible in the definition and doesn't put the constraints in until you map it.
Ari, you had one comment in the issues somewhere that I think is interesting. So you said if we arrange the branches in an array, we can use the indexing of that array as an implicit label. So I didn't quite pick this up, but we could pull a JavaScript here and say that that choice actually can be either a map like we see on the screen here, or it can be an array where the index actually takes the meaning of the map key of the label, actual setting, minimum device, and so on. I just don't have an example where I actually would like to use this, so I didn't set up such an example. But if we really want to benefit from this implicit ordering in the array, then we could do that. But we also need to warn people that having this implicit numbering, of course, is very brittle. So when they change the set of entries, the numbers change and all hell breaks loose.
Yeah. I mean, the using the array index comment was kind of potential way to get around of that. Like, we don't want to assign IDs, but yeah, you have very good point on the brittleness of that. My point was mainly, yes, we did discuss earlier that things like object ID and resource IDs maybe don't belong in the kind of information model level because they will be very different in different ecosystems. But I would argue that when it comes to enums, that they are rather tightly scoped. There's a good chance that like those same index or same values would be used across multiple ecosystems. And then like making less effort for the mapping file, you could just say, use the values from the information model as the values in the on the wire. Would be very convenient, but you don't actually have to, or otherwise all the ecosystems would have the same mapping, you know, have to do the same mapping to the IDs all over again. And using the array would be one way to implicitly get such indexes, but you do have a point that it is brittle. But I would still argue that having some way of indicating this somehow, either ordering or some way where you can easily derive the on the wire value would be very useful for enums, even if we don't want to do it for object IDs and resource IDs.
Yeah, so let me reply to that before Michael gets next. Basically, there are two cases where what you are saying makes sense. One is an ecosystem actually decides to do all their development in SDF. They no longer use their own weird way to write models. They write all their models in SDF. And for that ecosystem, it becomes very onerous to actually do their numbering in a separate file and set up all the back and forth pointers and so on. So for those ecosystems, we want to be able to put something like an ID in there, but it probably would be a good idea to label that ID with actually the name of the ecosystem. And in a converged situation, you may have this situation where there's just an industry standard way of giving R the number 0 and G the number 1 and B the number 2 or something like that. And there is no point in doing all the same ecosystem specific mapping for all ecosystems, because all ecosystems use the same mapping. And that would also be a place where we would want to put IDs into into the model, in this case the converged model, and then we wouldn't have a need to generate tons of mapping files. So I think there is a good reason to have that, but I also think there needs to be a naming scheme that avoids collisions.
Yeah, absolutely. We cannot dictate what is used. So I think it would be one natural way would be that the mapping file can always overwrite the default, or it's simply if you don't say anything, the default is used. But yeah, I can imagine there would be a lot of cases like when an ecosystem adopts a model from the converged set. But there is no conflict because they don't have that kind of a thing yet. Simply being able to use it as such would be convenient instead of needing to every time come up with a mapping. It's one small step less to do. And for those translators, that they could have, okay, this is the default case. I don't need any extra piece of code of doing mapping. I just do one-on-one can push the same values across. I think that would be valuable thing to enable. But again, probably we'll see with a few examples of mapping files, having those or not having those, if it makes a big difference. But my hunch would be that would be a useful thing to have, kind of default value for the enum.
So what I wanted to say was that I think first we kind of probably resolve that just relying on an array index, which is an artifact of the chosen representation, which is already an approximation, is probably not a good idea. But fortunately, we have a facility called default that already exists in JSON schema that we can use to specify these, that really has a well-defined way of behaving that probably suits our requirements, as well as another one called constant. So I think what we need to do is look at default and constant of JSON schema, which I put in both of these in some different examples in different places, and see if that meets the needs of explicitly defining something that we might use for a converged model, or for, as Karsten said, if there was some industry standard numbering that we could build in. See if default or constant or some combination of that when an overrides actually meets the needs that you want.
I think default is actually the totally the wrong way to express this, because default means the entire range is available. And there's if the value is not present, then this is equivalent to the value being present and having the default value. So if you think about minimum device value permitted here, if that's at default 0, this would mean whenever the minimum device value permitted is not there, it's a 0, and if it's there, it can be 45. And that's certainly not what is intended in this example. So we could invent something new, but we wouldn't call it default, because default has this very, very different meaning.
I think we need 3 or 4 more examples to use the point.
Yeah, I think Michael put up an example in one of the issues. Trying to remember which one this was.
Because we want an example with actually ID numbers, I think, if we want to resolve. But I think that yeah, I can't point to one either right offhand that I did that actually uses ID numbers. Maybe one, the ipso example, I just put it in like label or description or something for the time being, because I wanted to put it in a mapping file. But we also have constant, and if we make constant to be overridable, that might be a better way of saying it. But also, Karsten, as you say, maybe a different system of accounting for maybe multiple numbering sets in line or something like that might be something. If we have more use cases, we might find that's a better solution But yeah, I guess I get your point on default. It's something I just used in the examples, but yeah, we don't want it to be put in if you don't specify anything. That's not the desired behavior.
Harry,
I'm
go
thinking
ahead.
like a maybe good way forward. Like if we could like kind of do a three-way, I mean, three different ecosystems example of some existing enum and see how would it look like. I think that the choice pattern, what we see here, I don't see any obvious problems with that. I mean, one potential thing to think about would be this array approach, but good points on the brittleness. So maybe this const approach is better for it, and then see how it looks like. But I think this is going to good direction.
So if you have a tool that generates this, that tool, of course, can do the numbering and insert 0, 1, 2, 3, 4, 5 as labels into the choice. It's only when you do this manually that it becomes a little tedious, but it's not that tedious, and it also saves you from the brittleness.
Yeah, it's just not a good idea to use the array position to assign some ecosystem ID number that you're going to then depend on.
So most languages that have this IOTA kind of thing where you have automatic numberings have a way to switch to a position in the numbering scheme in the middle of the sequence, which is easy to do if you can invent your own syntax. It just becomes very ugly if you have to express it in JSON. By the way, there's also an email that Wouter, no, not an email. Mike, can you go to the issue list, issue number 2?
That maybe we should do that, and I do that by stopping my screen sharing, starting my screen sharing. Yes. Application window, that one. Is that too big? We want to go to number 2.
Yes. So right at the end, there is a comment from Wouter. Yeah, that's pretty much a prototype for the things that happen if you only have a hammer. Starting to encode information in the labels and having to parse the label to actually extract the structure. I mean, tools that extract JSON schema.org stuff and populate this from JSON schema.org won't have a big problem actually doing the renaming from whatever JSON schema.org uses to what we use. So they would rename both AnyOf and SDF enum into choice, and they would have to invent some labeling for the AnyOf case. I don't think that's a big problem. Ari, you're still in the queue.
Oh yeah, sorry, I forgot to leave the queue. But since now I'm here, you had a good point about this turning the SDF and description into JSON schema. And does this using choice for both bring us challenges there? That whether it turns to the enum or whether it turns into SDF any?
Well, if I were writing the code, I would look into the choice and see if any of the branches are singleton types with just a string in them. And then I would put all these things into a JSON schema org enum and put everything else into an any of.
Okay, so it's pretty straightforward.
I think so.
Good. Yeah, maybe actually developing a bit of that tooling would reduce some of Wouter's concerns on that. I wonder if we do have Wouter today.
He said he had a conflict.
Okay, too bad. But yeah, that could maybe be a useful thing to look at next in our hacking exercises on this, actually turning these constructs into standard JSON schema org for those who rely on those.
Yeah, next week is a great week to do a little hackathon. I mean, all the Americans are doing their virtual Thanksgiving, but we Europeans can work together and fix this.
Sounds good. Yeah, because I think like for me, the main reason why the plain enum doesn't work is that it's missing even a way to add description. Like if that's something what we really need, and I don't want to have an awkward way to add description, because I think that should be part of it almost every time. So we anyway need something more powerful than the plain JSO enum.
So Michael is also in the queue.
Please say that having a stable URI in the JSON pointer is pretty important also, and as we've shown that trying to maintain array ordering to create that stable URI is error prone, brittle.
So should we go back to the slides? Yeah, next slide. So this finishes.
Carsten, sorry, just on the previous one, did we really decide on what to do next? Because it felt like we are still in a bit of discussion. Should we implement the choice and test it out, as Ari said, or?
Yes. Okay. I think we build more examples and convince ourselves that the way forward we have discussed actually makes sense.
Okay, good.
The key points was that an example and that a mapping to 3 different ecosystems was key. And I guess because they would each wind up with some conflict that would have to be resolved, or some inconsistency that wouldn't just be pick one of the two, right? Guess that's what I understood about the 3 point. Maybe I was wrong.
Yeah, that's really one question that was kind of on the next slide, but not very visible. The question really we need to find out is, can we make any progress on the actual mappings? So right now, everybody has some form of mapping file in their various tools, and that's probably a good thing because it allows us to get these tools working. But the question would be, can we actually achieve some commonality in the mapping so we actually can standardize at least an overall structure for those mappings into which then, of course, ecosystems have to put in their ecosystem-specific material. And if yes, is this something we are going to aim for SDF 1.1, or is that going to be the first thing we want to work on for SDF 1.2?
Ari, you're on the queue. Ari, you're on the queue, and you're muted if you're. We can't hear you.
About that. So let me start again.
Go ahead.
So yeah, on Carsten's comment on the mapping file, yeah, I think absolutely makes a lot of sense to stress the structure. Things we have come up with and what are the commonalities there. For these different ecosystems, yeah, as Margaret Richardson was asking, like, yeah, I think it's a key that we pick multiple and then we see how well this system maps to each. And if we see something that doesn't work with an ecosystem, okay, then we have to come back to the drawing board. And to that extent, I was actually interested of asking like everyone here in the session today, like I mean, many of you must have worked on different enums in different ecosystems. Like any reflections you have right now, or if you have something. Few ecosystems that we are ourselves actively working on. But if you have worked on some ecosystems with these kind of structures, it would be very good to get your feedback on I mean, also all the issues, but this one in particular is perhaps something that you may have use on. So either right now or later on the list or in one of the interims. Just wanted to get that kind of if anyone has right now any comments on.
Okay, so with respect to the item number 3 on this slide, I think it indeed would be good to have an example that maps to multiple ecosystems, even if we don't standardize the mapping file exactly at this point in time. I think we can all understand the various syntaxes that we have been using for mapping files. So I still think we can examine this as part of examining this example and see if we really can close number 2 and number 5 in this way. Okay, this doesn't mean that the set of issues is closed or something. People can still propose new issues. And in particular, number 7 probably needs another set of examples to look at. So that would be another thing to discuss. And my point of view is that we really should go to a somewhat time-boxed release process. I don't have a detailed idea of what a good rhythm would be, but I think given that we have various holidays in the way, it may be a good idea to use December 8th as the date for a final draft for 1.1, which most likely will be a -02. And then do something like a comment period on that, or working group last call, or however you want to call that. And then we use the comments on that to have a -03 that is SDF 1.1 under the Christmas tree. So that would be my suggestion for this year.
Yeah, and then we will time a virtual interim around this December timeframe to sort of,
yes,
if there are final things to figure out. Absolutely.
Yeah, it needs to be in the week before the 22nd because we may need some editing to actually get this draft done.
Yeah, around mid-December. So
yes.
Before people head off for vacations or whatever happened this year. But yes. Any objections to that plan or concerns or so? Great. And I think we have a plan at least for the rest of the year. So, and then there's, I think the final one. Carsten.
Yeah, so for 1.2, I think we should really revisit our success factors and think about what we need to do to make this really work well. And of course, one success factor was enabling conversion of existing ecosystem models to SDF. So I think we have done that to a certain extent, and we are now opening up the domain, the subset of the ecosystem models that can be translated. But of course, we also have to keep track of the ones that cannot yet be translated into SDF1.1 and see if there is an 1.2 feature that would help with that. So that's one part, but I think the other part is to actually make SDF attractive as a development language for new ecosystem models. So imagining that say, IPSO or OCF might go ahead and actually write SDF on the way to their ecosystem models and either translate it into the legacy format or give up the legacy format or maybe manually derive their legacy format. But the main point about SDF should be that it's attractive as a development language. And that's something we haven't done very much yet, and where the actual stress testing would happen in the ecosystems. That wouldn't happen here or over at one data model. It would be the Bluetooth people or the Zigbee people or the IPSO people actually trying this out and see whether it's useful for them. So what we need is more ecosystems, of course, that actually try this, and good feedback links from those ecosystems, so we actually find out what they are struggling with. And that's something that we probably should focus on for early 2021. And from a time boxing perspective, I think we should aim for SDF 1.2 draft completed before IETF 110. So we have a little more than 2 months in the new year to do this. So that would be my personal goal, but of course we don't know whether that goal is realistic or not.
Okay. I mean, I think it's well, it's 2 months is not a very long time, but I think we'd have to revisit that early next year when we see if other ecosystems join up or not. But or I mean, as we get experience. But as a proposed, I mean, I think we can head for this.
Okay. So that was my last slide.
So thank you, Carsten. So we are now at the end of the scheduled content for this meeting. Is there any other business? Oh.
So I just thought I would put the calendar here. So there was a mention of this date, and there was a mention of this date. And what I heard was that we needed to have the virtual interim in here.
Yeah. And we need to decide it 2 weeks in advance, right?
So on this date, we need to decide which day we're going to pick in here.
Yeah. So I would say the 14th or the 15th of December.
Now, so there was some interest in using this slot on Monday that 1DM has sometimes used or regularly used.
Yeah,
that
yes.
might be the simplest ways to just go for that. And if that's wrong, then we could fix it.
Okay. I mean, it works works for the 1DM folks, I guess. The problem is it's not a very convenient time for folks on the Pacific time zone. It's
Right.
1400 UTC, so it's
7
it's a
a.m.
bit early.
14 minus 9. 3 a.m. No, I can't do math right now.
So it's early. But we can at least have it as tentative. I think we could do a doodle anyway, but maybe not so many dates, just the dates on the.
So maybe we'll do a doodle for 14th and 15th at a number of different times.
Yeah.
Does that make sense? If you want, I'm curious to know, because we have 50 some people, how many would come to the virtual interim? Like use the raise hand to give us an idea of how many we should expect to consider as terms of we have a range of opinions about time periods. So that's it, only 6, 7 people.
I hope we can get Wouter next time.
Yeah, so a few other people. Any comments from those who are not involved? Did you understand this work? Do you understand where it's going and what we're doing? Yeah, I specifically want someone to walk up and say, I haven't read the document, but.
So it's Nigel Davis here. I haven't read the document, but it seemed to make some sense to me, very much so.
Okay. Anything else? It's not forbidden to end early, but on the other hand, I don't want to give up the time if there's something useful that we can do.
If you don't mind me just asking a couple of questions, actually, I'm involved in work at ONF, and we're using UML as a modeling language, and we found that useful as for a representation. It's graphical, obviously not just textual. We actually have a set of tooling we have developed that we use to generate Yang from UML. Be interested in maybe just understanding how you would see UML, and also you talked about obviously different bodies generating their languages, or maybe abandoning the languages, but if not, generating languages from your more general language, more broadly applicable language. And I wonder whether you'd be thinking of generating tooling, or whether you'd expect them to generate tooling or whatever else in that area. So both use of UML and what your opinions are of that, and also tooling for language translation, which we found quite challenging, actually. But,
so you're generating Yang from UML. I'm curious, do you then serialize it to what? JSON, CBOR, XML?
JSON or XML, yeah, JSON. Yes.
Okay.
I mean, the tooling. I mean, obviously, a large part of this work is around tooling and enabling sort of machine translation.
Yes.
However, the focus of, the initial motivation behind it was to translate between the data models of different ecosystems.
Yes.
And so I think there's, I don't think, with sufficient amount of digital glue, sort of duct tape, you can translate from any system to any system. But I think it's but there is it's absolutely interesting. All kinds of translations interesting. So we had, during the hackathon, there was one participant who looked at translating SDF back into to and from Yang, for instance. So there is a lot of different, but it also, given that this is a bit of a domain specific, it's oriented around modeling these things, or the IoT devices.
Yes.
And so it has some kind of limitation on the general applicability, but it's definitely so that it's relevant. And I think we will, as we reach out at looking at additional ecosystems that already do their modeling, information modeling in UML, like OPC UA, for instance, we will encounter this. So interested, but not quite sure how to sort of map things together.
Yeah, I understand. No, it's fine. I was just generally interested in what your views were. So we found UML a richer language than Yang in some dimensions, and hence it was lossy as a mapping. So we lose some aspects of the model. We have to also orient the model in a particular way. We have to make it hierarchical more so than we would traditionally do with a networking model. We tend to see it as meshy, and you sort of get forced into bending a meshy model into a hierarchy. So we may have overdone that as well. And we may have been able to go for a forest of trees rather than a tree, but we seem to have gone for a single tree, and hence we've distorted our model in somewhat. But, anyway, so I was just interested in because we found some challenges doing the mappings. We've got a tool that runs, but it's not perfect. And we also found challenges getting people to write tooling.
So I mean, what we have, So what we have today is basically the tooling that can translate, I mean, SDF from SDF to OCF and to IPSO and back and forth. And we have looked at the others, Bluetooth and so on, that can do that. That's a bit more challenging. But yet, even with these kind of limited application, it still generates. There's a bunch of headaches, and as you say, I mean, there's lots of these kind of abstraction level headaches that you, in particular, when you need to address multiple receivers, so to speak. Yeah. So
very interesting. Anyway, thank you. Very interesting.
Yeah, thank you, Karsten.
Can you maybe send a pointer to the ASDF mailing list, pointing to a few of your UML models and the Yang you generated from that? So that would allow us to.
Yeah, I can try and do that. I can try and do that. So I've been to a couple of IETF meetings, some about 10 years ago. So get myself reintroduced into how to do that. But yes, I can do that. Yeah, certainly.
Yeah, very simple informal message to the mailing list is all.
Yeah, no, it's fine. It's great. Yeah, I've got some. We've got we're working GitHub, so I can send you links to that, and we have some documentation on the modeling mechanisms and approaches and so on in a very open, both of our repositories are very open. So in ONF you don't even need a password to get the documents through ONF, and the Git obviously you can see. So
we are not just interested in documentation. We are in particular interested.
No, we've got them. I've got the tooling and the models in Git. So it's more the documentation explains the mapping rationale, and then the tooling in theory supports the actual mapping mapping definitions. It's not perfect though, so we have to do a bit of hand crafting at the end of it. But,
so examples that you think are a good representation of what you're trying to do. That's probably the most useful part to have.
I try to do that. I'll try and get a bit more involved in this because it does seem very related to what we've been trying to do ourselves. We're looking for a consistent common modeling approach across multiple bodies. We actually work with MEF, ITT, and I think about others. MEF, ITT, ONF certainly at the center of the sort of relationship around UML. So okay, I'll aim to do that. Yeah, certainly.
So, any other final comments? We still have, well, half an hour, but we still have some time left. Other comments or questions or viewpoints or etc.
If all else fails, you can play the tutorial.
Yeah, that would be brainwashing. Yeah, if you haven't, please see the tutorial. It's good and it explains the basics of this work. And as I said at the start here, if you are part of an organization where you think this could be useful, please reach out to us and we can figure out how to work together, or at least describe the work we're doing to you. So I think we have, oh, here we go. Michael is quick. So this is, the times here are in time zone.
It's in the time zone as in mine is Eastern. So that would be 4 a.m. Pacific. and that would be 10 a.m. Pacific, or +6 to Europe is 7 p.m. So that's a bit late.
Okay.
And apparently
Great.
I'm available on all those times. So okay.
Yeah. Okay. So good. I mean, you will send out the link to that on the list, I guess. We will have a further work on this to wrap it up. I don't know if Karsten, if we should try to organize something next week for this, like a hackathon or something like that. Yeah, please let me know if you want to. We need to set something up.
What we organized last week was essentially the daily 1 hour sync. And that would be the same organization that I would propose for next week. So there's going to be a 1DM meeting on Monday. So you probably don't need a sync there. But having something like a 1 hour sync on Tuesday to, well, I hope not Friday, Tuesday to Thursday, might be the best way to get this happen.
Yeah, let's think about that so we can make it work out with people's schedules. I guess people are busy now, closing up to the vacations. But okay, let's try with that. That would be really good to have this finished. Good. Anything else? Calling once, calling twice. Then I think we are, unless Michael starts waving here, and I think we are done for the day. So thank you everybody for your time, and great having you here. I hope this was interesting. And if you now feel that you will want to hack this, please let us know so we can include you in the hackathon. They will send out the link on the ISDF list for the hackathon as well, for the upcoming hackathons around this. And as said, we have a plan to work towards. We have plans for the various open issues, and I think we can make progress with this in the near future. Okay, with that, I think we are done for the day. So off to sleep, all of you in the US. And for us, it's in Europe, as it's lunchtime. Okay, thank you very much. Take care. Cheers.
Thank
Bye-bye.
you.
Thank you. Bye-bye.
Bye.